So function notation. A function is always defined by f of x. So we would pronounce that by saying the function of x. That's how we would read that. And it can be the letter f. If you have two of them in a row, it could be f and g. Or you can have any letter in front of parenthesis x. And it's always still going to be pronounced function of x. So this letter doesn't necessarily matter. And once you get several of them, there'll be letters like F, G, H, J, K. It can be any letter. But it still just means that it is a function defining x. So f is the name of the function, and then f of x is the y value or the output for a given value. So whatever number that you have in parentheses, like if you look at number 1, this is my function. If you have a 2 right here, that means that you're going to, everywhere that you see an x, you're going to plug a 2 there, and then you're going to get a y value. Okay, so x is my 2, and then y is whatever I get when I plug in f of 2. So for part A, I would put in parentheses 2 squared minus 2 times 2. And then I work that out, so you end up getting 4 minus 4, which equals 0. So I would say that f of 2 equals 0. If I were to write that as an ordered pair, it would be 2, 0. So x would be 2, and then y would be 0. So try B. Okay, so you should get 15 for that. Remember, the biggest thing that I see people do is that they forget their parentheses, and then, or if you type it straight in your calculator and you put negative 3 squared without using parentheses, you're going to end up getting negative 9. But if you have negative 3 squared, you end up getting a positive 9. So always put in parentheses no matter what. Parentheses. Okay, if we look at number C, now we have an x in there, so, or a 2x. So anytime that you have a variable in there, you are replacing x with 2x. So everywhere you see an x, you're going to put a 2x. So everywhere you see x, replace with 2x.
So you're putting another x
Mm-hmm.
in? But with a 2.
Yeah. So replace with 2x. So what I'm going to do, here I have an x, and here I have an x. So I'm going to write it as, and remember to keep it in parentheses, going to write this as 2x squared minus 2 times 2x. So what I did is I put a 2x everywhere that I have an x. I'm just replacing it. Kind of like I'm doubling the function. And so then I'm going to simplify that. So if I have 2x squared, what does that become?
4x squared.
4x squared, good. Minus
Does that rule in the green follow? Oh, yeah.
mm-hmm.
That's only if you have two.
So what I did is I replaced everything with negative x. So I put a negative x to the left and a negative x here. What happens when I have a negative x in parentheses? I square the negative 1 that's in front, then I square the x. and it becomes a positive x squared. Then I take the negative 2 times negative x, and that becomes a plus 2x. So for part E, I have a negative in front of f of x. So I'm not changing anything inside the parentheses. I'm literally just switching the sign of everything in front of the function. So I'm going to put a negative sign in front, and then I'm going to write my function, x squared minus 2x. So what happens when I have a negative in front, if I distribute that negative, it becomes negative x squared plus 2x. And then for part F is the last one. So I'm going to take everywhere that I see an x. So this rule that I wrote in green, it applies to everything. Everywhere you see an x, replace with whatever is in parentheses. So in my mind, I think everywhere I see an x, I'm going to put x plus 2. So I just rewrite it. Instead of saying x, I say x plus 2. So in parentheses, x plus 2 squared minus 2x plus 2. So the first step, if you want to write out steps for this, the first step is replace. The second step is simplify. So I replaced everywhere I see an x, which is twice, I replaced it with x plus 2. So I put an x plus 2 here and an x plus 2 here. Then everything else stays the same. So now I want to simplify. So what do I need to do to the left? I need to distribute it, or I need to FOIL it. So I get x squared plus 4x plus 4. So it would be like x plus 2, x plus 2. And you FOIL minus 2x minus 4. Then I'm going to combine my like terms. So I get x squared plus 4 minus 2, so plus 2x plus 4 minus 4. Those would end up canceling. And you just get x squared plus 2x. Yeah.
Would you like to take x plus 2?
X plus 2, x plus 2, and that's how I ended up getting this.
No,
Would you factor it so it'd be x plus 2?
Oh, you could if you wanted, but I'm not going to make you. Okay, so for this one, no, you don't need a calculator. You're looking at a picture, and you're going to look at where the function is based on this graph, or based on this function. So f of 0, what I'm going to do is I'm going to look at x equals 0, which is this line right here. And I'm going to say what the y value is. So this is my x. What is my y? So my y is -2. So I would say that f of 0 equals -2. What about f of 3? I go to x equals 3. Where is that function? What is the y value? -4. So f of 3 equals -4. What about f of 8? Is there anything there? No, there's nothing there. So when I go to x equals 8, there's nothing there. So I would say that it does not exist. Or you could also say, and this is probably what I would want you to write on a test, that's the empty subset, or you just write a 0 with a diagonal line through it. Means like it's empty. So it does not exist. It's empty set.
So f of 8 equals empty set.
Right. And so then for D and E, now it's giving you the y value and it wants you to find the x value. So this 0 right here, so that's my y. So it's saying when y equals 0, what does x equal? And I could have several of them. So here is my line y equals 0. And how many times does it cross the x-axis? I have 1, to 3 of them. So I'm going to say x equals what? -5, x equals -3, and then x equals 6. Good. So then for part E, I'm looking when y equals 4. So when y equals 4, x equals what? 7. Good. All right, so for number 3, it says, is it a function? So how do I tell if something's a function or not? What is that test? Do you remember that? The vertical line test, yeah. VLT, vertical line test. So it's like I take my pencil and I draw a bunch of vertical lines, and if it ever crosses a vertical line twice, it's not a function. Like a sideways parabola is not a function because it crosses the some sort of vertical line more than once. So is this a function?
Yes.
Yes. It passes the vertical line test. If the inverse is a function, but we're not going to do inverses in this unit. What would the domain of this be? So kind of going back to what we did last lesson, remember?
With a bracket on them.
Yeah, let's just do interval notation. So domain would be parenthesis -4, 9, bracket, and then range. Yeah, it gives you the ordered pair. So would it be a bracket or parenthesis? Bracket, -3.5. And then where does it stop? At 5, and then that is a parenthesis. Good.
When do you do bracket? When do you do parentheses?
Bracket is when it's a closed circle, and then parentheses when it's an open circle. For part D, what is f of 3? So when does y equal 3? Or, I'm sorry, when x equals 3, what does y equal? -2, good. So when x equals 3, y equals -2. Then for part E, when does y equal 3? -3, good. So right here, so x equals -3.
Can you put like f of -3 equals 3?
No, because you could say f of -3 equals 3. Then I keep going. Not done, not done. Then I also have another one at x equals 6. What about what is f of 0? So when x equals 0, what is that? I have, so f of 0 equals -3. Then for G, when does f of x equal 0? So when does y equal 0? So I have 3 of them. X equals -2, x equals 4, and x equals 8 because it passes the line 3 times. So what I do is draw a horizontal line at y equals 0, and then I see everywhere that it intersects. When does f of x equal 5? So when does y equal, whenever y equals 5, what does x equal? -4, but then what do we say is there? So I'm gonna go back up. So when y equals 5, I'm at this line right here, and I have this open circle. So if I have an open circle, is the function defined there?
No.
No, so I would say that it is the empty set, or I would say it does not exist. So it's just like a 0 with a line through it.
So if it was a closed circle.
If it was a closed circle, then I would say whatever that x value is. I think it's like -3 or -2 or something like that. But in this case, since it's an open circle, it does not exist. So open just means that the function is not defined there. Where are my x-intercepts?
-2, 4.
-2, 0, 4, 0, which I've already answered for part G, and 8, 0. And then what is my y-intercept? 0, negative 3. Good. Okay, so for domain, if you're reading it from left to right, it goes from negative infinity. It stops at negative 3 because it's an open circle. Keeps going, keeps going. Here it does not stop because I have a closed circle, and it keeps going forever. So it only stops at negative 3. For range, it starts at negative 3, and it goes on forever because I have a closed circle at all points. Even though I have an open, it still trumps from the closed circle. Then for D and F, I'm looking at x equals 2 and x equals 0. For E, when does y equal negative 2? It's at 7. The reason why you don't say negative 3 is because it's an open circle. So it's not negative 3 because of the open circle. So it's not defined there. Yeah, and then where f of x equals 0 would be a negative 1, 8, and 4. For H, where is y equal to negative 3? It's on an interval. So since it's a horizontal line, it's everything less than x equals negative 4. So you could write it in inequality notation or interval notation. And then x intercepts and y intercepts. So for composition of functions, the only one that's something different or something new that you maybe have not seen before is the f of g. So it looks like fog, but it's how I would read that is I would say f of g of x. And basically what you're doing is you are, everywhere that you see an x in your function f, you're putting the whole thing of g of x, which is hard to explain out loud, but it makes more sense whenever we actually do it. So we have 3 different functions. We have f of x, g of x, and h of x. So we have 3 separate functions. And for number 1, we're just plugging in like x equals 2 for the 3 functions. So what we did on the last lesson. So f of 2 would be 5 times 2 plus 2, which is 10 plus 2, so f of 2 equals 12. G of 2, 3 times 2 minus 5, 6 minus 5, so g of 2 is equal to what? 1. And then h of 2, 3 times 2 squared. I square first, so 3 times 4. So h of 2 equals 12. Good. Then for number 2, it says f of g of x. So I'm going to rewrite this first. This is kind of this process that I take is I rewrite as f of g of x. So kind of like on the last lesson when everywhere I saw an x, I replaced with 2x, or everywhere I saw an x, I replaced with x plus 2. Now it's everywhere that I see an x, I'm going to replace with g of x. So I'm going to take the whole function, which is 3x plus 5, and I'm going to plug it in to f of x. So I'm going to rewrite this as f of g of x is 3x plus 5. Is it minus 5? Oh, it's minus 5. Sorry. So everywhere I see an x, I'm going to replace with 3x minus 5. So I'm going to rewrite f of x as 5 times, do what? You can just memorize them. It's not really a formula. Okay, so 5 times 3x minus 5 plus 2. So all that I did is, if I went back to my f of x, everywhere I see an x, I'm replacing it with 3x minus 5. That's what I did right here. Then I simplify. So step 1 is replace. Step 2 is simplify. So I'm going to distribute the 5, and I get 15x minus 25 plus 2. And so you get 15x minus 23. So I want you to try part B. I'm going to erase this just to give a little bit room. So my first step when I have g of f of x is I take this f of x and I rewrite it. So I'm going to say g of, what is f of x? 5x plus 2. So everywhere I see an x on g of x, I'm going to replace it with 5x plus 2. So 3 times 5x plus 2 minus 5. Okay, so now try part C. F of G is part A. F of H is for part C. So I would rewrite this as F of H of X. Then I'm going to replace H of X with 3x squared.
Hold on B, why did, so on the top it says G is 3x minus 5, why do you only put 3 in front and 5 in the back?
So I'm going to replace the x for f of x. So 5 times 3x squared, 3x squared plus 2 is 15x squared plus 2. And that will be my final answer. So now instead of f of g of x, now it has f of g of 2. So I'm going to rewrite this as f of g of 2. Then I need to figure out what g of 2, so whenever I'm doing these, I kind of work from the inside to the outside. So you might want to write that down. You go inside to outside. So I'm going to figure out what my inside is first, like what is g of 2? And then I'm going to go to function f. So I'm not even going to look at f until I have figured out what g of 2 is, which I solved for g of 2 in part B from number 1, but let's say that I didn't. I'm going to figure out what g of 2 is, which is 3 times 2 minus 5, which we said g of 2 is 1. So now I'm going to replace, come down here. So instead I'm going to substitute g of 2, I'm going to say f of 1. So everyone see how I got f of 1. So what I did is I replaced this g of 2. I've already defined what g of 2 is, it's 1. That's the answer. So I'm taking this and I'm substituting it to be 1. Now I need to solve for f of 1. So f of 1 equals 5 times 1 plus 2. So f of 1 equals 5 plus 2, which is 7. Okay, so I want you to try part B. You need to figure out what f of 1 is, which we've already done. And then solve for g of f of 1. Okay, so for part B, you should get 16. And then for part C, 242. Are we good? Yeah. Okay. Okay, so when you have a graph like this, now we have two functions. We have f of x and then we have g of x. They are both functions. So g of x, if I were to use different colored highlighters, f of x is this one that's curvy, and then g of x is the one that is more straight, like that. So for part A, you need to do the only difference is you need to do a little bit of math first, so like what we did on the last page, and then you look at the graph. So you look at the graph last. So what I will do, this is f plus g of 1. So how I would write that is, I would rewrite this as f of negative 1 plus g of negative 1. So it's kind of like I'm distributing. I'm combining f of negative 1 and then with g of negative 1. So I'm going to look at x equals negative 1. And where or what y value is that on f of negative 1? Negative 2. So f of negative 1 is negative 2. And then what is g of negative 1?
How do you know f of negative 1 is 2?
Also negative 2.
No. I'm looking at the x equals negative 1 right here. It's at positive 1, so plus 1. So here's what I did. Look at my picture. I look at x equals negative 1. The yellow function, which is f, is at negative 2. And then the blue function, which is g, is at a positive 1. So negative 2 plus 1 gives me negative 1 as my answer. Okay, for part B, f, g of 4. So basically, you're looking at this sign that's in between them, and that's what you're separating them. So I'm going to rewrite B as f of 4 times g of 4. So I'm going to go to my graph, and I'm going to look at x equals 4. Where's the yellow function at 4? 3. Good. Where's the blue function at 4? 1. 3 times 1 gives me 3. Good. For part C, I'm going to subtract them. So f of negative 2 minus g of negative 2. So I'm going to go to x equals negative 2. They are both where? Negative 1. So it's like saying negative 1 minus a negative 1. So negative 1 plus 1, which gives me 0. There's no difference between the two. So if they intersect, then there's no difference between the two. So it would be 0. Could save you some time. Okay, if we look at D, we have f of g of negative 6. So I'm going to look at, or positive 6. So I'm going to do the inside first. What is g of 6? Negative 1. So I'm going to rewrite this as f of negative 1, because we said that g of 6 is equal to negative 1. So all I'm doing is I'm substituting. Taking that g of 6 and I'm replacing it with negative 1. And now I go to negative 1.
And f of negative 1 is negative 6.
Negative 2. Good.
So that's the answer.
Uh-huh. So if I look at E, I'm going to rewrite this as g of f of 4. So I go to f of 4, and where is that? Three. So g of 3. So then I go to 3. Where is g of 3? 2. Good. So my answer is 2. So it just takes a little brain work. I don't know. It's kind of a different way of thinking. Then I look at f. I'm going to rewrite this as g of 0. So I go to x equals 0. Where is my blue function? Like g of 0 is what? 3. So I'm going to rewrite this as g of 3. And g of 3 is 2. Good.